Hello again. In the previous lesson, we studied function operations, function composition, and inverse functions. In this lesson, we're going to bring it all together into one idea. So, first of all, function operations combine outputs. So we can add them, we can subtract them, we can multiply them, and we can divide functions. Domains must include the restrictions for both functions. For quotients, also require that g of x is not equal to 0. Okay. And then in composition, composition means inner function is first. So this function goes first. So g goes into f afterwards. Inverse functions undo each other. Okay. So in this case, g of x into f is equal to x. And then f of x into g is also equal to x. Now, let's start by looking at the first example. Okay. So given f of x equals 2x plus 3 and g of x equals x squared plus 1. So we want to evaluate it based on these here. So the first thing we're going to look at is the expression f plus g of 2. So what does that mean exactly? That means that first we're going to find f at 2. So that's essentially taking f and replacing x with 2. So we have 2, 2 plus 3. So that's going to be 7, right? So now that we've done that, now we're going to find g of 2. So g of 2 is this here. So 2 squared minus 1. 2 squared is 4 minus 1 is going to give me 3. So g of 2 is equal to 3. So we have here and we have this here. Now we need to add them. So f plus g of 2 is equal to 10. Okay. 3 or 7 plus 3 is going to be equal to 10. So this is the final answer for that. Okay. Now let's look at this one. Now we're going to take -1, put it in G, -1, put it in F, and then we're going to multiply. So F of -1, which is 2, -1 plus 3, or -2 plus 3, which is +1. So F of -1 is going to give me +1. Now let's do G. As a matter of fact, I should have done G first. So G of -1 is going to give me -1 squared minus 1. G of -1 is going to be 1 minus 1, which is 0. Okay. So notice f of, and so when you multiply those together, you're going to end up with 0. Okay. So f of g of -1 is equal to 0. Okay. So again, the outcome is a +1 here. The outcome is a 0 here. And then the product of the two is going to give you a 0 outcome. Okay. Right. Then the second or the third part. So that's part 1, part 2, part 3. So we have the quotient of the two. So again, and notice it didn't matter as long as I'm evaluating. It didn't matter the order in this case. So G, we'll do G first. So G of 0 equals 0 squared minus 1, which is -1. So G of 0 is -1. Okay. And then let's do F of 0, which is 2 times 0 plus 3, which is 3. So F of 0 is 3. And then we're dividing those. So F of G at 0 is going to be we'll just say -3. Okay. All right. So, or essentially -3/1 or 3 over -1, which ultimately results into -3. Okay. Now, since g of x is not, um, since g of 0 is not 0, the quotient is defined. Okay. So as long as g wasn't 0, we're good to go. All right, let's look at example number 2. Given, so we have a radical here, and we have another expression. We're going to find the domain of the quotient and then state the answer in interval form. So the first thing we want to do is find the interval and then work from there. So we have f of x equals the square root of x plus 4. Because this is a square root, we have to set this greater than or equal to 0. Okay, so we know that x is greater than or equal to -4. Now we have to look at the denominator function. Okay, the denominator function, which would be x minus 1, right? Because we're looking at the f divided by g of x. So so when we understand that this is essentially what we're looking at, we have to know that this function cannot be equal to 0. So x minus 1 cannot be equal to 0. So x cannot be equal to 1 in this case. Okay? So x cannot be equal to 1. So the domain must satisfy both restrictions. X must be at least this, at least -4, but it cannot equal 1. So what does that look like? From a domain standpoint, that looks like, okay, -4, 1, union, 1, infinity. Okay? So that would be the domain of this particular problem. Okay? So we had to understand this restriction, then we had to also understand that restriction to be able to understand what this would be. Okay? Now, pause and try this problem down here. Okay, so given this and this, we have to find this expression and then find out also this expression. So again, this means that we're going to input 2 inside G first. So we're going to put 2, and then this is going to be 3, 2, minus 5, 6, minus 5, 1. So G of 2 equals 1. Now we're going to put 1 into F. So we're going to put this 1 that we just discovered into F. So F 1 squared plus 2, 1 plus 2, 3, F. So this is what we generate. Now, so the answer to F, okay, that is the final answer. Now, we're going to look at this one. So -1 into F, okay, so that means -1. Okay, so we have 3. Now we're going to put 3 into G. Okay, so now what does this mean? This means that actually this should be -1. Okay, and that would be the final answer. So notice that the order again matters. The inside function determines what happens first. Okay, let's continue. Example number 3. Find and verify inverse functions. So we have 2x minus 7, and then we want to find the inverse, then verify it. Okay, so remember, when we're verifying it, we need to write the function as function of y. Okay, change the signs or change the variables to y minus 7. Add 7 to both sides. Now we have x plus 7 equals 2y divided 2 to both sides. So now we have, I'm just going to write it over here. We have y equals x plus 7 divided by 2. Okay, so now after doing that, we see that this is our inverted function. Okay, so now we have our inverted function, and then we can essentially verify this. So remember, when we're verifying it, we take the inverse and put it back into this original function here. So the original function is f of x and that. So what we do is we take x plus 7 divided by 2. We're going to input it into this original function. So it'll be 2 parentheses x plus 7 divided by 2 minus 7. This simplifies, so we have x plus 7 minus 7. This checks out. These cancel off. We have x. So this checks off. So f of checks out. Okay, let's continue. Example number 4. Example number 4 says determine whether f of x is equal to the ratio of this one, and g of x is 2x plus 3, and determine whether they are inverse functions. Show both compositions. Okay, so in showing both compositions, we want to test this and we want to determine what it is we're looking for. So to prove that these two functions are inverse, we need both compositions to satisfy for x. Okay, so in other words, we need the we need this to be true. G of f of x equaling x, and then we need also f of g of x equaling x. Okay, that's essentially what this problem is asking us to do. So the first thing we want to do is basically substitute this one into this one right here. So we want to substitute g of x into f, right? And then the way that looks is we're going to say f 2x plus 3. And we're going to substitute that wherever we see x located. So we see x here. So we're going to substitute that, and we're going to write it as 2x plus 3 minus 3 divided by 2. When we simplify this, we notice that these 3's are going to cancel. Then the 2 is going to simplify, and we're going to end up with x. So the first composition works, right? Now let's check the second composition. The second composition says that we need to take f of x and put it into g. Okay, so essentially that would look like the function g is being multiplied by 2, and then we're going to, let's see, let's do that into g. I just want to verify what we did here. So this was f of g of x. Okay, so just want to make sure where we're going. So we got g of f of x pending. Okay, so now we're going to put the function of f inside this. Okay, so putting this inside here, we're going to substitute this entire expression into g of x. Okay, so this would look like 2 parentheses x minus 3 divided by 2 plus 3. Okay, the 2's would simplify to 1. Then we would have x minus 3 plus 3, right? And the final result would be x. So notice g of f of x simplifies to this, and this one also simplifies to this. So therefore, the functions are inverses of one another. So there you have it. An inverse party. All right, let's look at a common mistake. A student says that this composition means that correct the statement and give the proper context of this. Okay. So first of all, the the issue is this. This is a common mistake, right? Because most people look at this and they say, okay, this is multiplication, but this isn't multiplication. This is a composition. This is f of g of x. This means this means g of x is going into the function of x. That's what that means. Um, so that is not the same as a function of x multiplied by a g of x, because those two things are being multiplied together, and that's completely different than this right here. Okay. All right, just to recap, this is a summation of this. So we had, you can add, you can subtract, you can multiply, you can divide. And this is very important when it comes to domains. You have to understand the restrictions. And then don't get these two mixed up. Okay. Or excuse me, don't get these two mixed up right here, because sometimes you have to make sure order is important. So g of x goes into f, and then here f goes into g. Okay. And then this is a composition of functions, but do not get this confused with the product of two functions, because this is actually saying that g goes into f, right? And again, thank you for watching.